Hello everyone. Previously we had discussed on the topic tree, right? So today we'll be discussing on the topic trie. So as I've said earlier, tree, max heap and min heap is also represented in the form of tree itself, right? It's just a simulation of the tree, right? So we will trie is also similar to the this one tree data structure itself. It's represented in the form of tree, right? So see here, a trie is a tree-like data structure used for efficient retrieval of strings, right? So mainly for the strings itself, right? Just keep this in mind. This is very important, right? Usually trie-based problems, if you're giving interviews or if you are implementing certain things that is strings relevant, right? That is relevant to the string topic. Basically, we'll be making use of the trie, right? A trie is a tree-like data structure that is used for efficient retrieval of strings, especially for prefix based searching, right? Again, a trie is a tree-like data structure used for efficient retrieval of strings, especially for prefix based searching. Each node in the trie represents a character in a word, making it efficient for dictionary and autocomplete systems, right? Each node in a trie represents a character in a word, making it efficient for dictionary and autocomplete systems. So this is it for the trie, right? So this is it for the trie. Next, let's see the same thing with a very simple example, man. Implementation of the trie. Basically, first, what shall we do? Uh, let's define a node in the trie. So I'll just go with a class. This one is trie node. So this is fine. Now this will be. I'll just go with the initialization part. I'll go with def init method. So here this one will be self dot. I'll just go with the children here. Let me initialize this one to the empty. This one. Basically, this stores the character to trie node mappings, right? So this is fine. Let me remove this one, semicolon. And also let me go with self is underscore end. So let me assign this one to the boolean value false, right? So we are done with the initialization part. Now let's do one thing. Let's define the trie data structure, right? So I'll just go with a class. So let me give trie here. Trie. So this one, let me make this one capital T, man. Capital T. This is fine. So yeah, now let me go with def init. This is also fine. Now let me go with self dot root self dot root. So this one will be trie, right? So trie node, man. This is fine. Yep. Yeah, we are initializing the trie with an empty root node, right? So this is fine, man. Yeah, let me come out of this one entirely. Now let's do one thing. Let me go with certain methods here. So first, see, now we have successfully defined the trie data structure, right? So we have went with the initialization part as well. Nothing but we have initialized the trie with an empty root node. First one, this one. This is the beginning of the trie. Every time we have to initialize the trie with an empty root node every time whenever we solve the problem. Just keep this in mind, right? So we have to initialize the trie with an empty root node. Next, there is one method called insert. Suppose if you want to insert a character, right? So we will be going with the insert method for that. Suppose if we want to insert a character, there comes so this is used for the strings itself, right? So we have to insert the character, right? Individual character. So for that one, we'll be making use of the this one. What do we call insert method? Basically, character we can insert and make it a word, right? So we have to insert a word into that, right? Trie by individual characters, right? So for that one, we'll be making use of the trie this one insert method. So I'll just go with insert here, self comma word, self comma word. So this is fine. Now let's start at the root. First, I'll just go with node equals self dot root. This is fine. Next, let me go with the for loop here. For loop, sorry, for let's consider individual characters and the word. So we have considered word itself, right? So within the parameter. So this is fine. Now let me come to the next line. So here, what if the path doesn't exist at all, right? What if the path doesn't exist at all? So I can just write it in this way. If ch character is not in node dot children, right? So then we have to create a new try node for the character, right? So if the path doesn't exist at all, then we have to create that this one new try node for the character, right? That's what we need to do. So let me give colon here. So within the if condition, I'll just go with a node dot children of ch character. Let me assign this one to the try node. So this one will be try node, right? So this is fine. Now this works absolutely correct. So next part here would be, let's move to the child node. Means I'll just go with node. Let me assign this one to the node dot children, right? So node dot children. So this one will be ch. This is fine. So the next thing is, let's mark the final node as the end of the word, man, right? So this one will be node dot is end. So this one, let me assign this one to the true. Nothing but we are just marking the final node as the end of the word. So this is it for this one insert method. Very simple, right? So I have explained you step by step what we have done here, right? So next we have one more method. Nothing but if we want to search certain part of the word or the certain word from the group of words, so uh, we we should be able to do that, right? So we will be going with something called search method. We'll be going with something called search method, right? So let's write the code for same. So I'll just go with def this one search. So let me go with a self here along with the uh, along with the parameter word, right? So this is fine. Next, let me do one thing. uh, we have to start from the root, right? So we have to start from the root. So let me assign node to self dot root. uh, this is fine. Now after this, so what I have given here, yeah, this is fine, man. Let's see. So next, let's loop through the each character. We have to loop through the each character, right? So we are searching, basically in simple terms, we are searching for the complete word in the try, right? So let's do one thing. Let's go with a loop. I'll just go with the first ch, nothing but the individual character and the word and the word. So next I'll just go with this one simple if condition. Nothing but if the character path doesn't exist at all, word is not in the try, right? So let's write the same thing. If ch not in node dot children, right? So this will be node dot children. Then what we will do, then word is not in the try, means we have to return false in that case, right? So I'll just go with a return false. Else we have to move deeper into the try, right? So let's go with node equals node dot children of character, individual character. So we have to move deeper into the try and return true if it's the end of the valid word. We have to return true if it's end of the valid word, right? So here let me do one thing. Let me give return here. So we have to mark, right, basically, or we have to return true if it's the end of the valid word, right? So I'll just give your keyword is end that we have considered. Why this is not showing is end here? Just give me a second. Oh, this e has to be small actually. Just give me a second here. Is end, right? So now the error should be gone. Mm, what error we have? Return can be used only within the function. So, oh yeah, just give me a second, man. Here, let me make this one search first thing. So this is fine still. We are going with the search and this one, right? So these are the functions, basically methods, insert and the search. As we are going with a class, these are considered as methods. So I'm just going with the insert and search functions or the methods. So we are searching for the complete word in the try, right? So this is fine. Node, this is also fine. For loop, this is also fine. If this one, if the character doesn't, if the character part doesn't exist at all, then we are word is not in the try. Means we have, oh yeah, we have returned false here, right? So this is also fine, man. Then mm, I'm just going with a, oh yeah, this one indentation. So here, this one has to be node, right? So this one has to be here, and let me move this return here. This is fine. This. Indentation is a huge problem in Python, man. So now error is gone, right? So let's go with the example usage. Let's go with the example usage, right? So let's do one thing. Let me assign here try. So this is fine. This creates a new try, right? So we are just giving assigning t to try. So this is fine. Let me go with the variable t. Let me go with the insert. So we have already written the insert function or the insert method here. This one. Let me copy this one here. Let me paste it. I have already written. It's fine. So let's insert some word. I'll just go with the cat here. This is fine. Let me go with the cat. So next, let's print something here. I'll just go with mm, we have made use of the uh, insert method already. Now let's go with the search method. So let's search for cat first. So I'll just go with t dot so sorry sorry just give me a second, man. Yeah, we have written search. It is showing in the this one suggestions, right? So I'll just go with cat. Let's search for cat. This has to return the boolean value true, right? So because the word exists, so we have inserted a cat by making use of the cat, this one insert method here, right? So let's search for the word that we haven't inserted. I'll just copy the same thing and let me give here. Let me change from cat to car here. So r is not present on this one. This word car is not present on the this one try. So we have to get the boolean value false here, right? So let's do one thing. Let's try running the code. So we have to get the output true and false here, right? So we have inserted this one cat. So after this one, what we are doing, we have successfully written this one insert and search methods, right? So this is nothing but the uh, try class, right? So this is nothing but the initialization part, try node, right? So this is fine, easy, simple. Now let's try to run the code. We have to get the output true and false, right? So here we have inserted cat. Yes, cat word exists, so we have to get the boolean value true. We are searching for the car which doesn't exist in the try, so we have to get the boolean value false, right? So let me right click here, let me rename, let me copy this one, paste dot py, right? So if I hit the enter now, we are getting the output true and false, which is absolutely correct, right? So I have explained this one step by step clearly, man. Again, what's the definition say here? A trie is a tree-like data structure used for efficient retrieval of the strings, especially for prefix-based searching. So you can just copy this template. You can just keep this template, so whenever we are solving the problem on the try, so we can just copy paste the template and make the necessary changes accordingly with the question, right? So usually we'll be making use of the insert search. Usually we'll be making use of the insert and search, right? So within the try, so accordingly with the question we can modify within the search and this one search method, search and insert method, right? So this is it for the try, man. Very simple, right? So let me summarize whatever we have learned so far, right? So just keep this one thing in the mind, one sentence basically. A try efficiently stores and retrieves words character by character, right? A try efficiently stores and retrieves words character by character. It is ideal for the dictionary like lookups, autocomplete systems, and prefix searching. Again, it's ideal for dictionary like lookups, autocomplete systems, and prefix searching, right? So we are done with the try part, man. We are done with the try part. Next, we are left with only three topics. We have covered almost all the this one, all the important data structures. So we are just left with segment tree, fenwick tree, as well as the sparse table, right? So these three things, we are gonna discuss these three things. Finally we'll finish it off, right? So after this, I'll just make one videos along with the problem solving, right? So every day, so we will be solving anyhow. Every single day we will be solving this one problem from the code forces and one problem from the this one lead code. Along with it, from tomorrow we are done with the Python part, almost data structures, everything. So we'll completely concentrate on the design part, right? So we'll completely concentrate on the design part. We will be going with the dry principle, nothing but DRY principles, YAGNI principles, solid principles as well. And then let's solve this one, right? Some 25 to 30 problems, design problems using Python as well, right? So I'll just make one video per day from day after tomorrow. From tomorrow, tomorrow we are left with three data structures, right? That is segment tree, fenwick tree, and this thing sparse table. Let's finish it off, the data structures, this one part. And from day after tomorrow, let's do one thing. I'll just make one video that is completely related to the system design or the design part, right? So let's go with DRY principles again, YAGNI and solid principles. We have already discussed the OOPS concepts basically, right? So these three concepts, and then we shall solve some 25 to 30 problems or even more than that, right? So at least 20 to 30 problems. Let's solve this one, design problems using the Python. And the same thing, exact thing, we'll be doing in the Java. So Java, we will be going slowly. We will do everything in the Java, right? So we will pick every single this thing, what I call topic, from the scratch, and we will be doing with Java as well. So we had done the same thing in the JavaScript. Will not leave any freaking concept on Python as well as Java as well. Will not leave any concept in Java as well as Python, right? So we'll be doing everything, even more than the JavaScript. Whatever we had done in JavaScript, we'll be taking every freaking concept and we'll be doing it from the scratch, right? So we'll be doing it from the scratch. And from Monday to Friday, I had to work. So I'll be working along with it. So this thing uh, will be, this is my personal thing, right? So this I'll be continuing from day after tomorrow. Basically, we'll be done with the data structures part from day after tomorrow. As I've said, we'll be concentrating on the completely on the design part. First, we'll start from this one, solid principles. Then, as I've said, this one, YAGNI, right? Then let's solve some 30 problems. This one on the design problems, and then we'll be solving the HLD problems as well, but that I'll not be doing for this one YouTube. So I'll just this one, what do we call, brush up the HLD concepts using the Python, and I'll be uploading that one on the GitHub, so you can just go through the HLD as well, right, along with the LLD problems after solving LLD problems. So this is the thing we'll be doing for the next 100 days, along with the solving this thing, one problem from the code forces and one problem from the lead code. So right, and we'll be giving this one as well, what do you call, uh, contests as well, this one, and the code forces, code chef, as well as the lead code. These three things will not miss, right? So we'll be giving contests on these three platforms, right? So I hope that concept of try is completely clear, man. Right? So next, we'll be discussing on the topic segment tree. For now, this is it. Thanks for watching, guys.